All right. Good morning, everyone. Or actually, good afternoon, everyone. Welcome to our Leveraging Distributed HMI Technology webinar. My name is Adrian Lapola, and I'm OneSource Distributors Information Software Business Development Manager. Before we get started, just a little bit of housekeeping for today's presentation. The presentation is being recorded, so please, we'd like to just ask that everyone keep your mics muted. We will open it up at the very end for a little bit of Q&A. We also do have chat being monitored by both Martin Galanders and Matt Wright, two of our OneSource specialists, and the other one is our Director for Services. So feel free to chat in any questions. We'll try to answer them. And if not, we'll open up the mics at the end and try to answer it in the forum. So today's agenda, we're going to be talking about FactoryTalk software and FactoryTalk View SE. And then we'll transition to ThinManager software and then wrap things up with distributed HMI best practices. So what is FactoryTalk today? FactoryTalk software is actually built for supporting an ecosystem of Rockwell's advanced industrial applications, including Internet of Things or IoT. It all starts at the edge where manufacturing is going to happen and scale from on-prem to cloud solutions. Even though today we're going to be focusing mostly on the operational suite, there are 4 different suites of software packages that are out there. The first of which is FactoryTalk Design Suite. This specifically is in and around the design, configuration, and simulation of your systems that are out there. Some of the different software packages that exist in this area are Emulate 3D, the dynamic digital twin software, also FactoryTalk Logix Echo, Studio 5000, whether that's App Code Manager, Architect, View Designer, Logix Emulate through to simulation interface. We also have Operations Suite, where we'll be focusing on the View SE product. In this area, we have visualization, the historization, as well as MES software packages, everything from FactoryTalk Edge Gateway to FactoryTalk Historian to View, SE, ME. We have Analytics Augmented Modeler through to Logix AI. ThinManager software, which we'll be talking about, is in this area, all the way through to FactoryTalk Remote Access. The next is the Maintenance Suite. And this Maintenance Suite package, we have asset management as well as network management and predictive maintenance software packages. Types of software that you can find in this area are FactoryTalk Analytics for devices, Asset Center. If you have any kind of network or Stratix switches out there, our FactoryTalk Network Manager for full visualization of your networks out there. And then one of Rockwell's newer releases or acquirements are Fix CMMS, which is a computer maintenance management software. And last but not least, kind of getting to that new cutting edge cloud connectivity, we have the Innovation Suite. This is powered by the relationship with PTC, but it includes everything from IoT platforms, analytics, manufacturing operations, all the way through to augmented reality. Different types of software packages in this portfolio are ThingWorx IoT platform, augmented reality, FactoryTalk Edge Gateway, FactoryTalk Analytics Dataflow ML, Edge ML, and MES for both for the life science, automation, consumer packaged good and metal areas. So next slide, we're going to just talk about the operation suite, kind of pull into FactoryTalk View SE. So why does View SE exist? Traditionally, we had the configuration of terminals or panel views, in this case, the machines, they were done locally. You'd have one user sit in an office, go out there and configure that machine, and then possibly get out to about 4 machines. It's not too bad when you have four devices that you might be trying to manage. However, as you start adding these devices and they start multiplying, the ability to manage these kind of becomes a little bit cumbersome. So the thought here and the transition is to now start leveraging Rockwell's FactoryTalk software and try to migrate these away from where they are today in the panel views and moving them to a server environment. What this is going to do is we're going to be replacing these panel view PCs out there or devices out there with actual PCs, Windows PCs. We're going to transition these all the way through to the server. and move away from the managing out on each individual device, really centralizing that control. Next, we're going to talk about some benefits of a distributed HMI, which we're actually moving through in the portfolio. As we saw on the previous slide, this transition from a single HMI with local control to a distributed model, which really is going to help reduce the number of places required to maintain your systems out there. It's going to help give you a centralized control of your system, which visibility is really key. To be able to detect something is really going to be the first step to being able to manage these devices. So the first benefit is you're going to have a single point of configuration for the entire system, just like I showed in the previous slide deck. It's also going to give you the ability to kind of reduce your licensing costs. So no longer you're going to need individual license for each of the devices. These are going to exist up on a server, and you're going to be able to leverage those, whether or not they're user CALs or some of the FactoryTalk actual software license that we have. You can manage that and disperse those throughout your system. Also, the ability to control multiple machines from a single client gives you a tremendous amount of power, so you don't have to go out to each one of those individually like we had in the first slide deck. Also, centralized reporting, centralized security management, really helping you out with maintaining and securing your environment, as well as the ability to tie Active Directory, or in our case, Rockwell's FactoryTalk directory, to one single instance. This is also going to really help simplify your architecture out there. And a simple architecture is going to be key to trying to help your individuals out there that are trying to do a little bit more with a little bit less. Next, we're going to go over some FactoryTalk View SE components. So typical FactoryTalk View, there's 3 different types that we'll cover in the next couple of slides, but they're all going to be containing an HMI server, a data server, a local FactoryTalk directory server or Active Directory, as well as a FactoryTalk alarms and event server and clients. The first one, as you can see in this area, is the FactoryTalk View Studio portfolio. What this actually is the development environment for all of Rockwell's FactoryTalk View applications. This software is Windows-based. It's used to program both the machine level monitoring as well as control applications in a Windows environment. These applications can be run on Windows PCs, as well as PanelView Plus CE, PanelView Plus, dedicated terminals. First type in here that we're going to cover is a local station. So local station kind of brings you back to that one central location, and it's going to be made up of these same components that we mentioned a little bit earlier, but it's going to have one HMI server, one data server, one local, and that's what's key here, local FactoryTalk directory on that system, one FactoryTalk alarms and event server, as well as one client. You can think of this as a single standalone HMI that contains all the pieces of the FactoryTalk View SE system in one centralized location on that device. Basically, it's a powerful panel view that's running on a Windows box. The next is our network station. Network station, very similar to the local station. However, this is going to have a remote FactoryTalk directory instead of local, but it's still going to contain that same one single HMI server. It's also going to open up, and now you're going to be able to have one or multiple data servers, as well as one FactoryTalk alarms and event server and one client. Here you can connect to the remote directory, as I mentioned up here, because it's not local, which is really good for central management of your users, your computers, and your policies. It's going to also still allow you to maintain that single independent HMI in the system. Basically, this is a panel view running on a Windows box that is connected to a Rockwell Active Directory or FactoryTalk directory. The next set we'll cover, and we're going to be spending a little more time in here, is the network distributed. This is a FactoryTalk network application that contains several servers. They're all running on multiple computers, multiple clients connecting to applications simultaneously all at once. Each piece can be located individually or as part of a larger network, which means that all the parts, including the clients, are all on the same FactoryTalk directory, which is remote. Next, we're going to fall into a little conversation about ThinManager. This is where you'd still be able to leverage some of the FactoryTalk application software, including FactoryTalk View SE. ThinManager is a software that Rockwell has that provides centralized configuration, management, visualization, and security of your thin clients, your servers, or any kind of virtual machines that you're going to have out there. It's going to leverage terminal services based networks to do this configuration and management. And it's also going to help you ensure that your applications are securely delivered and available to the people when they need them, where they need them, regardless of any kind of system failures you might have out there on the plant floor. If you look here on the left, these are the content types. The content types that ThinManager can manage is everything from that panel view PC through to any types of servers you have, whether it's HMI, your ERP, MES, your CMMS, all the way through to web content, IP cameras, and more. I mean, you could share out Excel spreadsheets, anything that's got an IP address, some type of credentialing, as well as port numbers. It creates that secure socket. It's going to be content that you can share up through ThinManager through to delivery points. Those delivery points would be devices, so end devices from thin clients to actual PCs or mobile clients, and that's both iOS as well as Android. And then you have users, whether that's a specific user, a group of users, or a specific role of those users, and based on the location. And it can also be used in some combination of one or all of the above. Very similar to the other slide, this is now taking that management, which exists today in one single PC. So these are all individual PCs. They haven't been replaced with any ThinManagers, but on a typical PC environment, if you had to go and manage this, you're going to have to load an operating system on that PC, put any kind of applications like Rockwell's FactoryTalk software on those, any kind of antivirus you might want to run on there to make sure it's secure, any kind of moving parts or devices you're adding to that PC, as well as USB devices that might have been placed on it. If you're managing 1 or 2, 3, 4, maybe it's not so bad, but as you start going and you start managing these are all individuals. These are kind of like PCs, isolated PCs. So if you're doing patching, if you're worrying about security, each of these are their own, I'd say, threat vector point. A little more management is required for all of them. And that's where ThinManager software comes in. What we're doing is we're removing all of this and we're going to introduce a server environment. We're taking all of these brains and we're moving it to the server environment, and we're installing the operating systems that you traditionally install out on a single PC or multiple PCs, along with the applications, antivirus software and whatnot that can go through and control them. And we're going to swap out each of those PCs and we're going to replace them with a thin client or ThinManager cable device. What this is going to do is it's going to take the brains and the maintenance requirements needed to go and support these environments, and it's going to put that all up into the server. So if you're doing patching, if you're doing maintenance, if you're doing management, if you're sharing out applications, you do this all from one centralized location, and you only need to do it one time. You don't need to do it through all the individual PCs. This is a little bit of an eye chart, but I think it's a really good representation of where ThinManager sits with regards to the applications and content, which are in red, through to where this application and content is being delivered, which is in green. This is from users, control rooms, devices, or offices. It's that blue. It's that kind of, I'd say, the stickiness that allows the management between the content and the end device. In summary, ThinManager's main objective is really safely and securely deliver content in any combination of device, user, or location. Next, we have some characteristics of thin clients that are out there. So with regards to thin clients, they have characteristics all in common. The first is there is no operating system or firmware running on these devices, no spinning drives. They take up a little less power and energy. Also, they're industrially robust for plant operations. And then for connectivity purposes, they have an Ethernet port, allow you for that network connection, video connection, whether that's a VGA through to any kind of maybe display port, as well as USB connections. Also have a sound connection and serial, depending on need. Down here at the bottom is a link. If you follow on this link, it'll actually provide you ThinManager compliant or compatible devices. But even though your device may not be on this list, you can still test it out. It just means that it hasn't been tested and validated. Next, with the management of these thin clients, the benefits that come up, ThinManager really is going to help out with managing the thin clients by offering a lower total cost of ownership when compared to PC deployments. Oftentimes, it's going to pay for itself that first time you have a PC failure, where you don't need to go through and spend time to replace the hardware or have one of your operators go out there and spin up and reactivate that end device. Thin clients, especially the industrial grade type of terminals, are much less likely to fail because they have no moving parts, no hard drives, no fans. They also are more less susceptible kind of extreme temperatures or shock and vibration. And then also, when ThinManager clients fail, they can be replaced virtually by anyone. I've done it, and we have a ThinManager demo. If you're interested, let me know and we can come out and show you. You can, proof is in the pudding. I can let you go through and actually replace it at the end of the demo. Very simple. It's a matter of just replugging or removing the existing plugs, replugging in, and following through a couple commands to check and notify the system that you are replacing it. Also, with regards to security, there's no local storage, so nothing is stored on the device. If somebody stole the device, it would be a really expensive brick. There's nothing in there, no private information is being shared because it's all going to be running up and on the server. Also, in the case of a failure, when you do go and replace it, even if you are in the middle of doing some type of work, as that new thin client comes up, the other one's going to take over, and whatever you're working on is still running because it's in a server environment versus sitting there locally on that one local device. Also, it eliminates Windows desktops, which are another point for or threat vector for security purposes. You do not have to worry about patching and management of these devices because that is all done from one location. You're still doing it, but you're doing it once versus many times, depending how many devices you have. And then USB ports, they're disabled by default, except for keyboards and mice. So you can go through and re-enable that device if necessary, but by default, they are disabled. Next, we have distributed HMI best practices. So how do the control systems respond? Really key to keep in mind when you're going out and you're creating your HMI projects. First step is the system is going to need to be able to detect that there is an issue. And you also want to keep in mind that you want to keep this very simple, because to be able to detect something, you don't want too much information in there, or it's going to be harder to actually diagnose that there's an issue. Next, based on what is diagnosed as an issue, you're going to have your system be able to go out there and respond to it. If for some reason a system cannot go through, detect, diagnose, and respond or correct an issue, there is some operator intervention that can take place, but the operators are pretty much going to follow through the same practice. They're going to detect if there's an issue, they're going to try to diagnose the issue, and they're going to try to respond to the issue. You really want to ensure that operators have these visual tools that be required for them to detect, diagnose, and respond to alarms. This will ensure that they're notified and have adequate time to react before any kind of incident might be triggered. In this next couple of slides, I'm going to go through just a little bit of a scenario. So I'm going to ask you to count the number of fives on this screen. In this case, you can see everything looks very similar. It's kind of an eye chart. It's very important to keep in mind that high-speed recognition when there is an issue out on the plant is imperative for HMI design. In this example, go ahead and start counting the number fives, and then I'm going to hit the next screen, and I'll go ahead and write down the number that you have. All right, I'm going to pause there for a minute. It's kind of difficult to do. Once again, it's like that, where is Waldo? It's not easy. The number five looks like some of the other numbers, and your brain takes a little bit to go and actually find that number five because they are lost with the other numbers. They don't stick out. There's nothing kind of highlighting them. On the next slide, I'm actually going to add some color to the different numbers. So the number five is actually going to be green. You'll see the number 8 is blue, and so on and so forth. So I'm going to go ahead and put that up for a couple more seconds and have you try to detect the number 5 one more time. All right, as you can see, it's a little bit easier. Go ahead and write down that number. It's not a lot of time, but this is very similar to maybe when you're out there in the field and you're trying to react to these HMI screens and troubleshoot an incident. And the last representation, what we're going to do is we're going to have everything be white, and we're only going to highlight the number 5 in green. All right, go ahead and now count again. All right, at this point, I'll go ahead and leave this slide up, but if you compare your numbers, I don't know how well you are at counting through there. Some of you might be terrific, but it is a little bit of a task for you to go and isolate and pick out the number 5 in the first or second screen. In this case, we are only highlighting what is important, which is green number 5, and the color itself pops out. Your brain goes through this pattern, is able to find it, track it, and log it down. So this kind of anomaly detection is carried over to when you are developing your HMI screens. You want to keep that in mind, because a lot of screens today from operators, they go through and they create them very similar to these. They look terrific. Honestly, if you're putting up on the wall and this was a picture, you know, it looks good. Like a Christmas tree, or maybe some of those Where is Waldo painting or pictures that you have out there where you're trying to isolate and find them. They look good, but if you're trying to figure out if there is an issue on your plant or in your system, it's a little harder than if you had a system like this. System on the right, it's not as fancy with regards to color and whatnot. The only colors that pop out are the color red. However, in this case, boring is good. The reason boring is good, just like the number 5 location in the example we had in the first couple of slides, you can see here that your eyes are drawn to the color red. You're going to look at it, you can see that the tank level is high, and then you have an event up at the top. This same thing when you're out there on the plant floor. If you're given too much information, your brain will kind of shut it off. And it's going to be harder for you to go through and locate that there is an actual anomaly happening within your system. This is just a really good quote that we came across. You know you have reached perfection of design, not when you have nothing more to add, but when you have nothing more to take away. So this is really a good quote, because it highlights what we just discussed. When planning your HMI screens, you really want to ensure to make things as simple as possible. The intent is really to help your operators detect that there is an anomaly on your system. If you have too much data, the information becomes very similar, and it almost like spam emails or whatnot. It's really hard to see the forest through the trees. The operator may not be able to detect that there is an issue, hence they may not be able to react, thus creating some type of incident. Next, we're going to go over some system diagnosis recommendations. So what should be an alarm? It's an audible or visual means of indicating to the operator an equipment malfunction, a process deviation, or some other abnormal condition requiring a timely response. There are 3 criteria that go through here. So if any of these 3 criteria are not met, it really should not be something that triggers an alarm or an event. So the first is an alarm overload. What is an overload, an alarm overload? This is pretty much a situation where you have more alarms on your system and then can actually be physically addressed by a single operator. Next is prioritization of the issue. The actual action or process of decoding relative importance or urgency to a certain thing or things within your system. So you need to have some level of prioritization given within your alarms that you can characterize to say what is and what should, is something you should look at and something you maybe don't want to alert on. And the next is nuisance alarms. So this is not to be confused with false alarms. These types of alarms represent about 90% of the alarms that are out there, and they do not require any type of emergency response. So alarm criteria, these next items that we're going to go through, these all need to be met before you actually go through an alert and create an alarm. If any one of them are not met, recommendation is probably not to issue an alarm. So the first of these is, does the issue indicate a malfunction, a deviation, or some type of abnormal condition? If not, it isn't recommended to make that an alarm. Second is, does it require a timely operator action to avoid consequences? So if you're not given enough time for you to act and it's not within a certain amount of time, as you'll see in a next couple of slides, it's probably something that you do not want to alarm on. Also, is it unique, or are there other alarms that indicate the same condition? If you have other alarms or multiple alarms triggering that same on the same event, it's almost like crying wolf. Eventually, you really want to keep it simplistic. Instead of having 5 alarms off of one event, really makes a lot more sense, especially for your operator, to have one alarm for a single event be triggered. If not, you start getting overwhelmed. And the last is it better? Is it the best indicator of the root cause for that abnormal situation that you're dealing with? So once again, all of these should be looked at as criteria before you go through and you actually set this alarm situation within your HMI. So next is when to alarm. You want to alarm based on causes. So what is actually triggering the alarm? You need to know what is triggering the alarm so you can go through and actually detect it. There need to be some types of consequences tied to the cause of this alarm. So there should be some type of consequence of doing nothing. If you don't do anything, some type of event should happen. If no event follows, then there's probably an event that you don't want to alarm on. You can look here at the community emergency response chart here. The very bottom, starting in the process area, if you stay in that light blue area, this is just meaning this is typical process on a plant. You don't need to alarm on it. This is normal standard operation. As we move up into the green area, into the process control, if something happens in this green area, this is where the system itself can go through. It can detect, diagnose, and actually repair the issue. So once again, no user intervention is required. However, as we start moving up into the yellow, orange, through to red, if there is some type of operator intervention required, that is something that you definitely want to start alarming on. And then if operator is not able to respond in a timely fashion, then there should be some type of trip within your system that will allow the system to not go into either an incident or some type of loss of containment. There should also be some type of corrective action. So what an operator needs to do to the alarm for it to actually be either acknowledged, and the actual acknowledgement cannot be the corrective action. You don't want to just push a button and say, hey, I acknowledge the alarm. It should be something that you do to try to remedy the issue or diagnose it. And next is a confirmation. There needs to be some type of confirmation notifying the system itself that something has been done to fix the system to bring it back to normal. So the next slide is how to prioritize. So when developing in FactoryTalk View SE, you can actually create different priority levels. And the recommendation is to actually have 3 priority levels. And a common mistake a lot of operators out there make when they are designing their screens is that they prioritize everything with the same level. So no matter whether it's something that's high, medium, or possibly low, they trigger them all at the same level. Also, recommendation is instead of doing that, you want to implement that 3 level priority list that I mentioned a little bit earlier. An example of this on your plant floor is 5% of your priorities should be urgent, meaning at that top level, you don't want everything urgent, because then it's hard to see what is really urgent. If everything is urgent, then nothing is urgent. Just means that you have an issue going on your plant. 15% of your alarm should have high priority. And then the vast majority of them should be medium priority, because a lot of this stuff you want to be taking hold of it and reacting to it before an actual incident happens. So before you hit that loss of containment or incidents being triggered, loss of life, loss of money, you really need to trigger the right amount of alarms in that medium to high through to urgent priority before an issue actually happens. So with that being said, that's all we have for today's presentation. We're going to go ahead and open up the mics and ask if anyone has any questions. I don't know if Martin or Matt are on the line. Were there any questions that came in the chat during the presentation?
No questions in the chat, but yeah, please feel free to unmute or type your question in the chat if you have one.
Can we have a copy of the slideshow?
Yes, definitely. I will. Is this Tuan? I'm gonna unshare. I can't really see everything when I'm sharing my content. I'm
It's
gonna unshare for a minute.
it's Paulina. Paulina will
Oh,
definitely
Paulina.
send you a copy of the presentation. We'll also have a recorded copy as well,
Oh,
that we can share with the attendees today.
okay. Thank you so much. Is there any link? I know you posted a link in one of the slides. Is there any other link that we can use to get more information?
We can definitely share some links with you depending on what you're interested in learning more about. As with most Rockwell software, there's no end to the documentation we have to go through a lot of it. But if there's specifics, we'd love to talk to you about it and yeah, help answer any questions you have.
Okay. Well, my concern is that how would we incorporate that whole system to our older ones?
Yeah, so migration is basically what you're asking.
Yes.
And it really it depends on what you're migrating from and to. If you're migrating from RS-View 32, Rockwell internally has migration plans that they can help you move those HMI screens from RS-View 32 into View SE. So that's one route. If you have ME, whether they're panel views or ME station or SE stations, those can be incorporated into distributed SE model. You can bring those screens into a new HMI server on the SE side, and then you may need to reconnect tags depending on how it's structured. So that's another avenue that we can help you with. If it's from a competitive scenario, sometimes there's Rockwell solutions that fit well. If not, we have a whole host of system integrators that are capable of migrating third-party HMI systems over to a Rockwell View SE incorporating ThinManager.
Okay, we definitely have all of them, all of the above. So, so if we, when we do all the migration, do we just contact, who do we contact exactly?
Yeah, so you're free to reach out to either your account manager or Adrian or myself. All three of us can help navigate and bring the right direction to you. Eventually, it'll always come back to Adrian, and he'll be able to help from a technical standpoint. And then if you need partners to help you deploy a system, we work in collaboration to find the right solution for you, and we can help you in that regard as well.
That sounds awesome. I will just need any contact information I can get from you.
Yeah,
Too.
I'll when I send out that link, where it's going to be a little bit for us to publish this presentation, but as soon as that's complete, I'll make sure that I send an email to everybody on this list, everybody that has attended today.
Okay, thank you so much, Adrian.
You're welcome.
And
You're
Martin.
welcome.
No problem. Thanks for joining. And I see a question from Hector as well. Do you have a networking architecture example to deploy ThinManager? Adrian, do you want to take that question, or do you want me to?
Wait, say that one more time. I'm sorry, you broke up. What was the question?
Do we have a networking architecture example to deploy ThinManager?
Yeah, we have a couple different networking architecture examples. So Hector, we were also thinking about in a couple weeks heading out that way. Maybe we can touch base again, but a lot of that depends on what you have in place. But in essence, it's gonna really be dictated based on what, how many servers you have in that environment, how many end devices, but something we could definitely touch base with. I'll put a note in here so when we come back out, we can have that conversation.
Hector says sounds good. Thank you.
Awesome.
Any other questions today?
All right. If that's it, we'll go ahead and end the presentation today. Please feel free to reach out to either Martin, myself, or anyone else out here at OneSource, your account manager. Let them know that you were part of the leveraging distributed HMI and you had any specific questions or anything else you'd like to talk about. We'd love to get out there and talk more with you. Thank you.
Thank you so much.
You're welcome. Have a good rest of your day.
You guys too. Bye-bye.
Bye.